Today on Do It, I'm going to be showing you step by step how to create a 3D model of this MakerBot build plate leveling knob so that we can 3D print it as a replacement. Alright, so let's see if we can't guide you through my modeling process for this knob. Something that I brought up in a previous video that's worth mentioning again is that SketchUp is not always the best choice when trying to model something that you know you're going to 3D print, for a number of reasons that I'm not going to go into detail in this video, but I did find a great resource, this website here, iMaterialize. Let's get rid of that ad. iMaterialize 10 tips and tricks for 3D printing with SketchUp. It's a really great rundown of some of the ways to get around certain features of SketchUp that might hinder your model from 3D printing as best as possible, in the best way possible. So I'll leave that link in the description, but it's a really great write-up with some good images and some great tips if you're looking to use SketchUp for that reason. You always have to start by using a template. I've already scrolled down here to a 3D printing millimeters. I'm going to use millimeters because that's how our MakerBot is always in the units of millimeters. So this template isn't really anything more special except that it comes with a component already on the zero axis here that represents the print area for a great number of 3D printers out there on the market. And I can show you if I select it here and go to my dynamic components menu, you can change the 3D printer that you are seeing and its print volume. So here, by default, it shows MakerBot Replicator 2. And here's what makes me laugh. So we're going to be using a MakerBot Replicator Mini, this one. But the title shows, watch this when I apply and change, a Replicator Z18, even though the print volume is representing a Replicator Mini. It makes me laugh. If you show a Z18, print volume is accurate, but then the title changes to Mini. So I don't know who needs to contact Trimble and let them know that their software has a slight typo in their component here, but anyway, worth mentioning. So I'll go ahead and put the volume for a Replicator Mini here, even though it says Z18. And one last thing, I don't really want to be staring at this the whole time, so in my layers, I'm going to create a new layer, call it the printer template, and we're going to move it to the printer template, and we're going to blank that out, make it invisible, so we can model on a nice clean area here. So let's get started. So it isn't too crucial to be 100% accurate on some of the parts of this knob that don't house important components. So I'm just going to kind of race through a lot of these measurements and modeling, and I see that the outermost diameter of the knob is 35.5 millimeters. So since SketchUp asks for everything in radius, I always like to have my calculator handy. 35.5. Not that I can't do this in my head, but it's always good to check. 17 3/4 millimeters. Off we go. The height of that part of the knob, the thickness of it, is 9 1/4 millimeters, so 9.25 millimeters. And we're off to a good start. It looks like the center cylinder coming out is approximately 13 centimeters in diameter. Half of 13 is 6.5. So let's find our inference to the center here. 6.5. Enter. And let's go ahead and extrude him his full height. And from the very bottom of the model is 17 centimeters. And since we've already extruded 9.25, 17 minus 9.25 is 7.75. From here, let's create sort of the hollow features of the knob. This not only is going to keep it more lightweight, but it's going to save us a lot of material when we 3D print. So rather than create this all solid, let's create those little cross supports and hollow it out where it's supposed to. So rather than move this guy, I'm going to bring the axes up, and I can see that the thickness of the supports of the little cross members are just shy of 2 millimeters, and just to keep things simple, I'm going to round it right up to 2 millimeters. So if I offset each of these by 1 millimeter, those outer guides now represent the outer edges of the supports. And just in the spirit of keeping things simple, let's make the very outer, I think I had a measurement. Let's take it again. Yep. Very outermost part of this was 2 millimeters as well. So let's go ahead and select it and use the offset tool. 2 millimeters. Now we have all the geometry we need to reference these guys. I'm going to do this on all 4 sides. There are different ways of doing this. Once you create one quadrant a certain way, you can certainly use the rotate tool and array those features, but this isn't too bad if you're only creating 4 anyway. So there's all 4, and if I did it correctly, I can erase some of this connecting geometry, and that will link them all where they need to be. And these 4 faces are indeed their own faces. So when I push-pull them down, I should be left with this outer ring as well as the 4 little quadrant supports. So in the interest of keeping as many things uniform as possible, but also conserving, my strength, integrity of the part, I want to leave at least 2 millimeters of thickness of this bottom part. So since we extruded him 9.25 millimeters up, let's just bring him down 7, which should leave me with 2.25 millimeters of material at the bottom here. So select one face, hit 7, down he goes. And quick tip, that SketchUp remembers the last value of whatever function you used. So rather than selecting and inputting that value, I'm just going to double click and it will continue to use 7 as its value. And now we're starting to get a part that looks a little bit like our original knob. So it looks to me like the diameter of the cylinder that extends from this face is 10.5 millimeters in diameter. Half of 10.5 is 5.25. So that's our radius, 5.25. And its height from the very bottom is 24 millimeters. And since we've already extruded 17 of that, looks like we're going up 7 millimeters. Oops, wrong tool. Push pull, this face, 7 millimeters. So the original knob has its own attractive, exact threaded insert, but I had to go to the hardware store and find my own. And the height of it is exactly 6.5 millimeters, and the outer diameter of all the threads is about 5.8 millimeters. So what I'm going to do is make my hole here 5 millimeters in diameter, which is 2.5 millimeters, 2.5. And I'm going to extrude it down the exact measurement. It's kind of a risk. Our 3D printers aren't so finite to get to the 1/10 of a millimeter. But let's have some fun. I'm just going to extrude it down and go exactly 6.5 millimeters and see what happens when I thread that guy in here. And I'm also planning on using some plastic specific Loctite super glue. There's also a hole on the underside here in the center. And I know we said we weren't too crazy about making everything exact, but it's not too hard to do this one, so let's have a little fun. The diameter of that hole appears to be about 7 to 7.5. I'm circling my calipers around. It looks like about 7.25. Let's just go 7.5. Half of 7.5 is 3.75. Hey, look at me go. There's the center. 3.75. And I'm going to use my depth gauge to find how deep it goes from this side, because there is in fact a step off, a difference in the diameter of the hole the deeper we go. So let's put the depth gauge of my calipers there, and it looks like that part of the hole goes 14 millimeters down. And we are almost done. To finish this off, we've just got to make this hole completely hollow. If memory serves me right, the screw in the tensioning part of the leveling plate is rather long, so it's going to go beyond the height of the threaded insert that's going in here. So what I think I'm going to do is actually take this cylinder down to meet the face here, and we've got our hole. See that we're seeing through all the way up to the sky, and in this case we're seeing right through down there. So our threaded insert ought to go right down to where we extruded the where we extruded the hole to initially. But if the screw in the MakerBot does in fact exceed the threads there, it has space to travel through. So we're good to go. The last thing I'm going to do isn't really necessary, but the original knob has these ridges all around the circumference of the outer knob. We're not going to do them all, but we are going to do a handful, and we're going to use the array tool. This operation is going to get a smidge complicated, so bear with me, but we are going to triple click this entire guy and make him right click and make him a group. And if you've done your work correctly so far, in your entity info, it should say solid group. If you are in a previous version of SketchUp, go to Window, Entity Info. Well, as far as I know, in previous versions, Entity Info is in here near Model Info. But it should say solid. We're going to create all 8 of our little segments for our thumb and finger positions based on 1. So since we've got a nice 2mm theme going on, if I click at this intersection of the guide to the group, bring it out, and I'm going to hit 2, enter, keep it locked on the green axis across to the other guide, and then bring it back to the intersection. Now here's where it gets kind of tricky. SketchUp, even though it's not the best because of its segmented circles, notice we have midpoints and endpoints, it chooses a default that's very cooperative with splitting a circle up into even parts. So we're going to finish this face by working our way around the edge of the circle. So I'm going to snap here, and that should complete our face, and it did. So we have a completed closed vector right here. Let's push-pull down to the bottom. And before we go grouping anything, this is where we're going to triple-click and use this guy and array him all the way around the model. If you're not familiar with this, pay attention, but any move or rotate tool you use in this program, if you tap the control key, notice there's a little plus sign next to my cursor now, and that means it's going to create copies. So as my rotation plane and origin, as it shows right here, I'm going to select the intersection of guides we've created. The origin might work too, but I want to use the top face. I want to use the top face of our selection. So there it is. There's our intersection and our center point of rotation. And I'm going to bring it out to the center point right here. Click, and notice I'm rotating around this circle, but it has deleted the original. This is where I tap control and it toggles our copy. If I go exactly 45 degrees, it's going to line up exactly with an endpoint of segments along this circle. So again, this is one of those points in where SketchUp is not the most ideal for creating solids for 3D printing, but if you know what you're doing, it's not that bad. So I can just snap here, or I can type in 45 degrees, enter, and before I do anything else, we are still technically within that command. So I can do an array if I just tap X, in this case it means times, and I'm going to do 7, enter, and it completes the rotation command an additional 7 times at 45-degree intervals. Using my selection tool and holding Shift, I'm going to triple click, to get all the rest of them. Right click, make them a group, and you'll notice that it's a solid. There's no conflicting geometry, and I can easily use my outer shell and select the other solid, and voila. All those interior pieces of geometry disappear as it creates. When I click, you can see a solid group ready for 3D printing. Now all we got to do is send it off, export it, and 3D print the sucker. And now just to clean it up, I'm going to go to Edit, Delete Guides. And if you really want to see things as they stand, you can go to view and uncheck axes, and there he is, kind of floating in space. Our brilliant little solid MakerBot leveling plate knob. To export for 3D printing, can't leave it as a SketchUp file, so you go to File, Export. Now this is where in the past you used to have to go to the extension warehouse and get the STL extension. OBJs work pretty well here, so if I export 3D model, there's a whole lot more options than there used to be. And in this case, I'm going to export as an OBJ. I'm going to leave it as knob, hit export, and that should go into the majority of slicing softwares for 3D printers. Hey, thanks for watching. I'm going to go find out if this new piece works, and in the meantime, you can check your own out on our Thingiverse page. Once the piece is all in place, I'll be posting the build and implementation video, so look for that. The link will be, somewhere around here. That's it for this one, but you don't have to wait till our next video, because Do It is on social media now. So look for us on Twitter and Instagram under the handle @DoItProjects. See you next time.